Thanks for coming to the session today. I'm really excited to chat about some of these projects. We're going to capture a breadth of essential work taking place in Puget Sound today. This is a continuation of the morning session. If you guys are here in the morning, we tried to make them flow into each other. That the habitat implementation strategies identify as key research needs that will enable and accelerate habitat recovery planning and implementation. So we're going to be here about 5 different projects. A handful of these are the marine vegetation, some innovative and critical projects going on, and some are out of the water. Oh my gosh, marine scientists, get out of the water. And we're going to go talk about some rare biodiversity and ecologically important land projects, some whole habitat database development, mapping. So Adrienne will start us off. And I will say we've been told to keep the mic. I was doing a bad job as close, not moving it around. So if you can try and keep it right here. Yeah.
Hi, everyone. My name's Adrienne Akmajan. I work as the marine ecologist for the Makah Tribe, and I'm going to introduce our HSIL funded project. This is our first year. We haven't done field work yet, so I'm actually going to frame a lot of this talk just around what this project means to the tribe and why we developed it. Uh, the ocean and the ocean resources are central to the Makah Tribe's culture, subsistence, economy, so much so that in the 1855 Treaty of Neah Bay, the chief was famous for saying, "I want the sea, that is my country," and securing um, usual and accustomed fishing area of over 1,500 square miles in the Strait of Juan de Fuca and in the Pacific Ocean. And in present day, fisheries makes up a huge part of the tribe's economy. And as you may be well aware, there's many court cases and other statutes, but tribes act as co-managers with the state and federal government for many of the marine resources. Now, in 2017, the tribe followed in the footsteps of President Obama in making a national ocean policy, developed a Makah ocean policy, and that really guides a lot of the work that those of us who work for the tribe, in particular the Fisheries Management Department, do. And I'm going to put up a bunch of different tenets here. You do not have to read all of them. But to name a few, ensuring that the tribe can continue to utilize resources for generations to come, preserving the tribe's maritime heritage, including social, cultural, economic, and historic values, improving the tribe's knowledge on living resources, and managing those resources with an ecosystem-based approach that considers both traditional and scientific knowledge. And then, taking all that together to enhance the tribe's ability to respond to changing environments. Now, I'm just going to talk about one portion of the tribe's marine use area, which is the actual bay, Neah Bay itself, which since time immemorial has surely had lots of changes, but in the last 150 years since the signing of the treaty, has seen lots of change in terms of marine and maritime infrastructure, including in-water and shoreline structures. And that's really changed as well the ecosystem in the bay, which is home to kelp beds, eelgrass beds, and subsistence harvested clams. Of particular note, lots of different structures, but in the 1940s, a federal breakwater was constructed between the mainland and Wada Island that actually effectively cuts off the bay, the inner portion of the bay from the strait, except at the mouth that you can see there. But more recently, there's been a couple of projects where some of these structures have been removed, and that has made the tribe think a lot more about just restoring the overall health, water quality, et cetera, of the bay. And that kind of was the impetus for this project. And I apologize that my bullets and photos didn't work, but in 2024, Washington DNR removed a big derelict structure. This is not the photo of it. Sorry, that's for the next bullet. And in the same year, the tribe partnered with the National Marine Sanctuary Foundation and removed a sunken piece of the I-90 floating bridge that had been in the bay for 30 years, as well as about 15 or 16 derelict vessels. DNR had also removed a bunch of creosote pilings. And so this really opened up a lot of thought about what are some other things we can do to improve the bay. And that kind of goes into my project, which I came out with a bit of this double approach, and you'll see this in literature called a two-eyed seeing approach, where you're combining Western science with traditional knowledge. uh, to kind of get a whole picture of eelgrass and what that means in the present and in the past for Neah Bay and for the Makah people. And we're going to do both the Western science, some boat and land-based surveys for eelgrass extent, eelgrass present, health and disease, as well as water quality and sediment quality monitoring. And then we have a couple of community engagement events planned, including one happening next month, dinner and discussion, and working with the Makah Museum, the Makah Culture and Research Center, to look at historic collection archives, ethnographic records. And so essentially learning more about both the current and historic uses, thoughts, culture around eelgrass or seagrasses. And then the ultimate goal of this, so this year, 2026, we're doing all of that nice data collection. Um, and we're going to then next year do some test transplanting, hopefully informed by all of this great science, so that we can look at how transplanting might work in Neah Bay in the future. And that's all I have to share. Thank you.
Thanks, Adrian. We'll have some like broad questions at the very end for folks. So, yeah. Okay, Megan from Skagit Watershed Council.
Okay. Hi, everybody. I'm Megan Corbier from the Skagit Watershed Council, and we're very excited to be a recipient of this grant as it will help us share the story of salmon habitat restoration in the Whidbey Basin. So I'd like to start with some background on who we are for those that might not know us. The Skagit Watershed Council is a community partnership for salmon. We are a public nonprofit with 45 member organizations. One of the things we do is coordinate salmon restoration in the Skagit and Samish watersheds. We're one of 26 watershed-based lead entities around Washington that facilitate the Salmon Recovery Funding Board, or SURF Board, grant process to fund projects that restore and protect salmon habitat. To map and track these projects, we use the Salmon Recovery Portal, or SRP, which I'm going to be talking about a lot for this project. So the Salmon Recovery Portal is publicly accessible. This is their webpage, and it helps us relate future, current, and past project achievements to salmon recovery goals. So accurate and consistent data in this database is essential for tracking progress, meeting regional and state reporting needs, and facilitating decision-making. Incomplete and inconsistent data limits our ability to assess impacts and share our success stories, which is why the 4 lead entities in the Whidbey Basin are working together to improve data accessibility and reporting ability in the SRP database. So we'll be working on projects across the Whidbey Basin, which is seen here as a whole, from the year 2000 to present. So how will we accomplish this? Soon we will begin our inventory of the SRP database for consistency and completeness with the help of a contractor. While doing this, we'll work on a shared data dictionary, consulting with RCO and PSP staff. The data dictionary will help us ensure that data is consistent across projects, geography, and throughout time. So we will then compile a list of projects that we would like to add to SRP to increase the funding sources represented. Currently, we only have RCO funded projects in SRP, and by incorporating other funding sources, we will get a more accurate picture of habitat recovery within the Whidbey Basin. So after finding more projects to add, we'll then fill in gaps and clean data where we can by using our connections with project sponsors in our watersheds to obtain this project information. We'll enlist the help of about 60 organizations in total to research their past projects, helping us fill in missing data and checking for quality. Next year, we will incorporate improved project maps on our websites showcasing the data. We'll also create a user's manual for current and future SRP users, including would-be basin lead entities, project sponsors, and potentially other lead entities. The user's manual will help us ensure quality data into the future. So in the end, we'll have increased capacity to compile, analyze, and ensure quality data within the Salmon Recovery Portal database so that we can share the story of salmon habitat restoration, both within our individual watersheds and across Woodby Basin as a whole. And that's it. Thanks.
Yeah. Okay, I think we have Bart from DNR, Washington State DNR. Okay.
All right, thank you. So I'm Bart Christian. I work at the Nearshore Habitat Program at DNR. And today I'll give a short overview of our HSIL-funded project to monitor eelgrass in South Puget Sound. And I want to start out by saying that there's a lot of people working on this project, and I've listed everybody on the title slide over here. So this is a team effort. Okay, so what is this project? So this is a collaboration between DNR and Pierce County to basically survey about 180 kilometers of Pierce County shoreline in South Puget Sound using towed underwater videography. And the goal is to get a good idea of the area and depth distribution of eelgrass in the study area. So we are also going to do a change analysis and compare it with any historical data sets that we find. And all of this will inform the Pierce County 2029 Shoreline Master Program update, as well as the statewide kelp and eelgrass health and conservation plan. Okay, so what have we done so far? So this project started in 2025, and we started actually with a running start. So we did an RFQ process. We got a contract for vessel support in place. We finalized our QAP, and we were able to do half of our planned field surveys in summer 2025. This basically means that we did towed underwater video surveys at 971 transects spread over 97 sites. So that's every other site in our study area. And all the data has been processed as of last week. So that made me able to put a little map on here. So this is, the top of Carr Inlet. And all the lines that you see here are sites that we surveyed, and all lines are transects. So basically what we do is we have a research vessel back up at high tide as close as they can to shore, drop a towfish with a towed underwater video camera system on it, and then we drive the transect line down to minus 15 meters mean lower low water. And so this camera collects footage. It flies 1 meter above the substrate. And then we score that footage at 1 second intervals for presence, absence of eelgrass, as well as the non-native Nanozostra japonica name change. So what you see here is the green parts of these transect lines are eelgrass. The bluish parts are basically Nanozostra, or a mix between Marina and japonica. Okay, and we can then take that information and do fun things like estimate eelgrass area, uncertainty around it, depth distributions, and so on. So what you see here on this map is eelgrass area at the site sampled. So all the colors you see is places where eelgrass was present. The darker the color, the more eelgrass at a site. If you see the brown hashed lines, it basically means that the site was surveyed, but no eelgrass was found. And if you see a black outline but no color, that's a site we plan to survey next summer. So what we found so far is that eelgrass was present at 47 out of 97 sites sampled. And that's a lot more than what I expected. And Nanozostra japonica was present at 11 locations. Just in general, eelgrass is more abundant in Carr Inlet than in Case Inlet. But the majority of eelgrass beds that we found were all fairly small, so less than 2.5 hectares per 1,000 meters stretch of shoreline. And all the eelgrass was actually very shallow. So 95% of observations are between 0 and -4 meters mean lower low. and the majority was actually a lot shallower than that. And then, fun little fact, we did also witness an enormous amount of large inverts, sea stars, sea cucumbers, and so on. Okay, so our next steps in summer 26, we are going to do surveys at the remaining sites. We will also spot check the location of the shallow edge using RTK, and that's important at places where you both have Moraina and Japonica, because it's kind of hard to distinguish between the two based on video alone. I will have our data analyzed by early spring 27, and then we'll do that comparison with historical data and have the final report published by June. And while this is all ongoing, we have discussions with Pierce County on how they can best incorporate our results into their future planning efforts. Right.
Okay, we have Zach from the Seattle Aquarium next. Or Zachary, should I full name you?
Got my water, got my timer. Okay. Okay. All right. Well, hello, folks. Thanks for joining us. My name is Zachary Randell. I'm a senior research scientist at the Seattle Aquarium, and I am excited to talk about our HSIL-funded project, developing and implementing and testing novel methods of conducting benthic surveys using remotely operated vehicles, ROVs. And I want to give a shout out to Megan Williams and Reed Thompson, two full-time staff on my team, and Keenan Johnson, Clyde McQueen. They're volunteers, but they provided invaluable software and engineering expertise to the team. Okay, so just to set the stage here, I think many in this room are going to be fully familiar with bull kelp and kelp forests in general. These are incredibly important ecosystems culturally, and they're also vital in terms of the direct and indirect connectivity that they provide. Shout out to Hannah and PSRF for this amazing graphic that she put together. We have seen big declines throughout Puget Sound, and in response, we've seen various legislative and state entities marshal in response. Now, one kind of shining area of that is the floating kelp indicator, as seen here on the left and as discussed this morning. And there's quite a bit of information about floating kelp throughout Puget Sound. So you have a variety of methods that can get at that, from diver methods, kayak, drone, airplane, satellite. And you have far fewer methods that can really tackle the benthos. You mostly have scientific scuba divers, particularly reef check, all throughout Washington. But we with this project have really sought to build out another method in the form of ROVs to help gather information about the benthos. So the invertebrates, the kelp, the fish, the substrate type along the seafloor. So we have three main pillars for this project. Number one, an ROV diver methods comparison. I'm going to zoom into this the most during this talk. And then we also tested how well can we utilize ROVs to monitor bull kelp restoration throughout the summer. Spoiler alert, stick with divers, absolutely. Especially in the heat of the summer, you can't see, let alone fly a vehicle through that. So great, lesson learned. Number three, expansion of a bull kelp habitat suitability model. I'm not going to touch on this too much. We're expanding it right now to a broader spatial extent for all of central Puget Sound, but I'll briefly touch on that at the end. So I'm going to zoom into the ROV diver methods comparison, and I'll briefly touch on results, but I really want to try to put out a seed in your brain for how best can we utilize this tool, the ROV, going forward, given this new window of observation into the system that we have. Okay, so for the ROV diver methods comparison, we conducted ROV surveys right alongside reef check divers. You may be familiar with some of the core transects, so fish, invertebrate, kelp, algae, and UPC. You have 6 30 by 2 meter transects. So we established 4 of these sites. I'm just going to show you 2 of them in Elliott Bay. And we had the ROV fly above the meter tapes, and then the Seattle Aquarium reef check divers went down on the same day, about an hour apart. So very similar one-to-one methods comparison. And you can see the telemetry tracking for the ROV over there on the left for a site at the Elliott Bay Marina Breakwater, and then right offshore of Centennial Park. Now, we're still validating the last of the data, and I'm not going to get into the stats of the exact one-to-one results, but I can tell you qualitatively what we found. And that is, number one, divers are much better at capturing objects and cryptic species, the invertebrates that are under algae. There's really no substitute for interacting with the benthos, especially in our temperate ecosystems, sifting through the vegetation to find what's underneath. Number two, divers are much better operating in the thickest areas of the kelp. We have been able to operate the ROV in kelp forest, especially in Elliott Bay, but then you get a bit north or more out towards the Western Strait, there's going to be kelp that you just can't maneuver the vehicle through. So divers are truly indispensable here. Number three, the ROV captures a tremendous amount of information regarding percent cover. So for your red, green, brown algae substrate type, we get a top-down snapshot of the system. So the ROV is about 0.8 meters above the substrate, above the seafloor, and we can take those snapshots across a large spatial extent, and we can extract a lot of information from that. So we're going to kind of zoom in on the percent cover slightly. And just to orientate yourself to what this looks like from the diver's perspective, if we have a single 30-meter transect and you're looking at UPC cover, the diver is going to gather 30 of those points. And so 11 of them may be encrusting red algae. So you get a 36.7% encrusting red algae for a single transect. And you typically average those transects to get site level inference. Now for the ROV, this is a real 100-meter transect, and I kind of zoom in on 30 meters of it. The green dot basically represents a downward-facing photo. We get a photo every meter. And then within a single photograph, we have 50 randomly distributed percent cover patches. So these are 224 by 224 pixel patches, and we've trained a machine learning model to classify automatically what is contained within each one of these patches. Now, something I want to note is that these are randomly distributed, and that kind of plays into our statistical inference, and that then also gets to how best do we want to utilize this window of observation going forward. So this is a lot of data, especially as part of this methods comparison. So we flew the ROV on either side of the 30-meter transect, just like the divers do their swath invertebrate search on either side of the 30-meter transect. So that's 60 photos per transect, 50 data points per photo. That's 3,000 data points per 30-meter transect. And this is just basically a summary of 3,000 data points. So these are kernel density distributions. And so on the upper left, for example, you can see green algae ulva. This is from one transect, a shallow transect at Centennial Park. The median here is 32%. So the median photograph has 32% green algae coverage. And there are many, many photos with 50 and even up to 75% green algae percent coverage. So there's a lot of green algae here, a lot of different types of red algae as well, quite a bit of sand, pebble. These are soft. This is a soft sediment system. And now what I want to articulate here, when it comes to comparing the ROV to the diver transects, we're easily able to do that. So we can calculate an average across all our photos to get a transect level average. We can compare that to a transect level percent cover for the divers, and then same for the site. But I think this kind of skips over one aspect of the sampling that I'm pretty excited about, and that is because these points are randomly distributed, we can model percent cover, the proportion of various percent cover categories at the scale of the photo. And that means you can examine how that proportion changes across space. Now, you may say, those photos in sequence are not going to be independent replicates. They're going to be spatially autocorrelated. Absolutely. We can harness that autocorrelation and look at how that pattern changes across space or changes across depth. And I think that could be really useful in instances where we're trying to understand how these species, understory species, may be distributed across space or the extent of their spatial patchiness, for example. And just one small example, this is kind of an older figure from some work with the Port of Seattle, but across numerous transects and photos within transects, because we can model at the scale of the individual photograph, you can generate pretty specific probability functions, in this case, for the probability of having sugar kelp across a depth gradient. So because I don't have too much time, I'm just going to really briefly touch on a couple different open source pipelines that we've been able to develop thanks to HSIL support. Number one, we've trained up a machine learning model to process our color correct our photos for us. We hand edited a lot of images and used those pre and post hand edited pairs to train up a model that now does the color correction for us, which is great. We also use a different type of machine learning model to extract percent cover data from the images. This part goes really fast. Verifying, validating those machine learning model predictions, that takes a lot longer. So to do that, we've actually spooled up, it actually just went public yesterday, KelpQuest on Zooniverse. So volunteers from all over the world can go to KelpQuest and basically view our real image patches, including the machine learning model prediction. And you can say, yes, that is ulva, or no, that is absolutely not ulva, which it is not. That's a bull kelp blade. And so those volunteers are helping us validate those data so we can turn right around and do the actual statistical analyses. So we try to make this as open as possible. So it's all on GitHub, and this links to a variety of information there. And this is just a quick note that Megan Williams on my team is putting together an expansion of the habitat suitability model started by Gray McKenna back in the day. It's using environmental layers from the Salish Sea model. And like I mentioned at the beginning, she's in the process right now of expanding the spatial extent to central Puget Sound. And just a quick kind of next steps, what are we looking at? HSIL in the April 10th quarterly report, you will have a full draft of our first field methods manuscript for all this work. So detailing the different versions of the ROV, the hardware, the software we've developed, and the field protocols themselves. And we're really excited to be teaming up with Reef Check to develop a understory kelp indicator to sit alongside that floating kelp indicator. And then lastly, we're starting to really think about what it looks like to have diver and ROV surveys where not where the ROV's flying right alongside where the diver is, but thinking about let's have divers do what they do best. So let's have a Reef Check site, and then the ROV is doing something complementary. So perhaps that's a perpendicular transect across depth, for example. And so we've actually trialed that with the Port of Seattle and Elliott Bay. And as you can see, we completed about 24 of these perpendicular transects throughout Elliott Bay to see how well that worked, and it actually worked pretty well. So we're starting to seriously think about what it looks like to implement some combination of Reef Check sites plus these perpendicular ROV surveys to capture broader spatial patterns across depth. So with that, thank you very much, HSIL. We couldn't have done this without you all. You all helped us staff up and build up equipment and build out these field and analytical protocols. So thank you very much. Oh, questions? Oh.
Okay, since Zach's one of the longer talks, we have a couple minutes for some questions before we go to Joe for a second. If anyone has anything, we can hold him hostage up here for a minute.
Be shy.
Hi, Zach. Great talk. I am interested to hear more about the scalability of the ROV surveys. Like, how long does it take you to survey what kind of area, and how are you envisioning scaling it up to a larger region if you are?
Yeah, it's a great question. The field work itself goes relatively quickly, especially depending upon what version of the ROV we have. So that methods paper that's going to come out details 4 different versions, with one being off the shelf, as low cost as possible, battery powered, very, very simple, working up to more complicated power supplied from the top side, power going down the tether, and then the ROV can basically stay down all day. So for this, for example, these are transects that took about 10 minutes each. And so we were able to complete those in about an hour. And so that part can go really quickly. anchoring the vessel, getting the vessel kind of setting up a little bit. That takes some time. But we can complete probably 9 of those transects easily in a day. For us, what has really been the longest part is processing the images, and especially validating the machine learning model predictions. And so that's why we've put a lot of work into kind of honing those workflows as much as possible.
Beckon from the back row. Thanks, Zach. That was great. For those of us who spend a lot of time snorkeling higher up in the water column for forage fish and juvenile salmon, do you have images or could you have video pointed up?
Yeah, absolutely. You can put as many different cameras as you want on the ROV. And I was just talking about it at lunch. Whenever we get the ROV out of a bull kelp bed, we typically run the vehicle up or right at the surface of the water. And so we have lots of instances where we've seen, for example, in Elliott Bay, the bull kelp growing, and then the kelp crabs have eaten all the bull kelp blades. So we get these images of naked bull kelp stipes essentially sitting in the water. So yeah, it's absolutely a method that can be used to gather information right up at the surface.
Okay.
Yeah, I'm just wondering if you can say anything about how well the machine learning is doing after you compare it to the validation data, and then how the process of training the model, if that was relatively easy or if it took a really long time.
Yeah. So we used a framework called CoralNet Toolbox. It's not to be confused with CoralNet itself. CoralNet Toolbox was originally a set of open source tools that a researcher named Jordan Pierce put together to expand CoralNet, and it has since turned into a whole one-stop shop for anything you could want to do with machine learning and underwater imagery. So with CoralNet Toolbox, the training itself is relatively straightforward and fast, as is deploying the model. For us, what we found is really validating, kind of reviewing the model predictions is a bit of a time sink still. That being said, retraining the model, once you've verified model output, that goes pretty quickly. And it's a GUI, a graphical user interface. You don't have to be doing programming or anything to train the model, deploy the model, retrain the model, et cetera.
Matt. Zach, this is a softball question. It's not actually about the sport softball, but it could be construed as a softball question, but I think it's really important. Elliott Bay has some beautiful kelp beds. The Seattle Aquarium is right in Elliott Bay. That's an amazing underwater robot. Please tell us about some of the outreach you have done and some of the outreach you might want to do with this amazing tool.
Thank you, Jody. That's a great question. It just so happens that April 8th, 9th, and 10th, we're going to install an underwater docking and recharging station right above the seafloor on a pier piling at the aquarium. And full credit to UW, Applied Physics Lab, Blue Robotics, and Ybotic. There's a long-standing 5-year collaboration that the aquarium just jumped in on the last year of, essentially. But that collaboration developed this technology that integrates into the Blue Robotics ROV that allows the ROV to essentially dock and recharge its battery. So we'll have that pretty much staged at the aquarium along with a cart where we have a big outdoor display and we can stream the videos from the ROV, from a forward-facing camera, downward-facing camera. We can stream it online. So I think I'm really excited for the opportunity to share Elliott Bay kelp forests and kelp forests in general with the public. It's going to be new infrastructure and new resources for the aquarium to kind of shake up how they tell stories and interact with the public. So very excited for that.
Last one. Oh, yeah, lucky me. Okay. Yes, thank you so much, Zach. It seems like another really powerful advantage of the ROV is it just can access deeper water than traditional diver surveys would. And I'm curious if your team has any plans to start deploying it for more deep water surveys.
Yeah, absolutely. That's definitely one of the strengths for sure. The deepest that we've gone is, I want to say, 42 meters down Turn Rock, or around 145 feet. Amazing flight. But in general, yeah, the ROV is rated to 100 meters. Our tether is 125 meters. So I think there's a lot of opportunity to start doing surveys deeper down. And that's part of the motivation for the perpendicular transects. I think the next avenue, we do some diver operated video surveys at the aquarium, and they go along blades of reef structure, and the divers stop at about 60 feet. And I think we'll just take the ROV down the same blade and just see what we can do. Yeah. Thanks, folks.
Okay, we have Joe from the Washington State Department of Natural Resources for our last talk.
Thank you. Set up. Let's do this. Yeah, so my name is Joe Rocchio. I manage the Natural Heritage Program at Washington DNR. We're on the upland side of the agency, so it's kind of cool to be amongst the aquatic side. Unfortunately, we don't get to interact as much as we should. So I had the pleasure to tell you a bit about our HSIL funded project to develop what we call essential conservation areas, a blueprint for protecting Washington's, I should have terrestrial biodiversity in the title. Molly Webush, who's also here, as well as Tiny Ram Gramberg, are also part of the team. In fact, they're doing most of the technical implementation of this work. And so, yeah, we're excited to share this with you all today. So our goal is, again, to develop this map and geodatabase of these ECAs, or essential conservation areas, within the Puget Sound Basin. And actually, the HSIL funding helped us construct an argument to the ledge to provide funding for us to actually do this statewide. So HSIL is helping us do this in the Puget Sound Basin, and we have some other monies. I think it's actually Climate Commitment Act funding to do similar work across the entire state. So our long-term goal is to have this for the state of Washington. But most of our effort right now is on the Puget Sound Basin. And what kind of our impetus for doing this is going to help us identify potential future state natural areas, which is one of the primary objectives of our program, as well as to develop a product that we hope will help our conservation partners conduct more efficient and effective conservation on the landscape. In brief, our approach is for the HSIL project was to compile and update existing biodiversity data. I'll talk a little bit more about that. But that included doing some field work, some surveys, as well as developing species distribution models for our rare plants. Then we are going to use those data to delineate these essential conservation areas, which I'll touch on. We are assigned various ranks to them so that we can use this geodatabase to help prioritize and drill in to where we think conservation should be prioritized. And, you know, I used to work for the Colorado Natural Heritage Program 20 years ago, maybe. And we used a similar concept there. And what I found as an ologist working with planners and trying to bridge that conversation, planners loved this concept because it didn't really matter the species information, all that. Sometimes you can see the planner's eyes gloss over. But these maps of important sites really drew their attention. And so what we were able to do is use that as kind of the flag, and then we can then kind of open the hood and see what's actually important for each one of these sites. And so what we found in talking internally at DNR and our partners is that there was an interest and need for this here in Washington State. Before I get to the project, I just want to quickly mention a bit about our program so it provides some context as to why we have a great interest in this work. So our program was, so the Natural Area Preserve Act of 1972 called for the establishment of a natural heritage program to do a couple of things. One was to maintain a classification of the state's what are called natural heritage resources in the RCW. And in effect, what we're doing is maintaining lists of rare species, specifically rare plants and ecosystems. We then go out and look for these on the landscape, and we use those data, and we're mandated to share this information to inform decision-making, including the selection of state natural areas. So again, our primary core functions is addressing a few questions. What is it? Which rare species or which species and ecosystems do we have in the state? Which ones are rare and imperiled, and thus conservation priorities? Where is it located? We're almost 50 years old. So over the past 50 years, we've compiled over 6,000 records of the locations of these across the state. And then we also ask questions about how are these things doing? How are these rare species and ecosystems doing on the landscape? We have various ways we approach that question, but one of the most critical is rarity or imperilment of each of these. So we use a systematic method that's used by heritage programs across North America. And so it's a metric-based approach to get at that rarity. And again, I've mentioned this many times, but sharing the data, that is our core function, getting this information out and into the hands of people making decisions. One of the other mandates that the ledge gave us is to develop a state of Washington natural heritage plan every other year. We're getting back to doing it every other year. We had some hiccups for a while there. But what we do in this plan is this is where we update kind of our official lists of conservation priorities. So which species and ecosystems are rare, we share that here. And there's a lot more in the plan, but for the nature of this talk here, it's really this conservation status. Again, which species and ecosystems are state endangered, state threatened, or state sensitive. And so, I mentioned we're almost 50 years old. We've collected 63, actually that number up there is wrong because I won't get into why, but we do have some animal records, but we don't share that because DFW has the statutory mandate for animal information. But we have about 6,300 records for rare plants and ecosystems across the state. A lot of information that we've collected over the years. And it's not just our work. We do a lot of field work in the summer to identify these, but we're also accessing information from a variety of resources. That information is already being used to inform decision-making. So federal agencies will use the information to determine whether to list or delist, rare species. Numerous state agencies use our data to implement different regulations and policies. Local cities and counties will use it for critical areas ordinances or, associated with the Growth Management Act, mainly in the wetland realm, but we have had some counties interested in prairie and oak information related to critical areas. And land trusts will use our information to help them prioritize and consider the conservation values of sites that they're interested in acquiring. And then DNR uses it for maintaining forest certification, as well as implementing the policy for sustainable forestry. And then I mentioned this already, but a big task that we were given is to nominate and select sites to be included in the statewide system of natural areas, and these data are critical for that. So why do we need these ECAs, right? We're collecting all this data, it's already being used, but we feel that ECAs there's an additive effect that they bring, and really related to landscape planning, as well as site scale planning. I kind of already mentioned earlier the landscape planning approach. It really simplifies the conservation message. 6,300 records of locations of rare species ecosystems. That's a lot of data to work with. And then there's the scientific names attached to it, right? It can get daunting for many end users. And so we feel the ECAs is going to help kind of bridge and really communicate where those conservation priorities are at in the landscape. And then at the site scale, it really helps us think about where we want to be conducting conservation. And I think I need to be moving quicker. And so I'm skipping over a lot of what we've done. I'm getting right to the ECA development, but we're developing these essential conservation areas kind of in a stepwise process. So what you see up here is kind of the raw data I've been talking about, the location of rare ecosystems, which are these orange polygons, and then the rare species, which are the green polygons. So again, this is what we provide right now for people to use to inform decision-making. We are using a GIS-based approach to kind of develop our first draft of ECAs. We're calling them proto-ECAs. And it's just a GIS exercise of aggregating and creating a polygon around element occurrences or those rare species and ecosystems that are within a half a kilometer of each other. And then what we're doing is that Molly and Tynan are then going through each of these proto-ECAs and looking at them individually and drawing these essential conservation area boundaries. And these boundaries are intended to represent the area that we feel is critical for management and acquisition in order to preserve those rare species and ecosystems. In other words, just avoiding the actual footprint of those ecosystems and rare species isn't necessarily enough to preserve them. That's what's missing right now in the decision making. So we're hoping ECAs will fill in the gap. And you can see in this example, the resulting ECA at this site actually ended up kind of aggregating 3 proto-ECAs. What you see here are a series of balds, which are kind of rocky prairie-like ecosystems that occur on the west side, and there's a couple of rare plants associated with them. So we've kind of compiled them into one essential conservation area because they're along similar ridge, so there's genetic exchange. There's an ecological reason we put them in one site. So kind of following through with the example on the right, the other thing we're doing is assigning these various ranks to each one to help prioritize how to use this map. The first rank is what we call a biodiversity rank. And again, this is a part of a heritage methodology. So there's differences or definitions for each of these ranks, but a B1 would be the best example or one of the most important sites in the state for biodiversity. And whereas a B5, it just has general value. This particular site ranked as a B1. It has outstanding biodiversity significance because not only because of the rarity or impairment of the species and ecosystems present, but the number as well factors into this. Management urgency, as its name would suggest, is how quickly do we need to get on site and implement management actions to prevent the degradation or loss of those species or ecosystems. M1 being now, to M5 saying, we don't really need to get out there anytime soon. This particular site had a management urgency of M4. We didn't see a lot of non-natives out there. We didn't see a lot of threats. So we don't think it's urgent, but we still want to monitor. Protection urgency rank, again, is how quickly do we need to get out and acquire this site in order to preserve these. And actually, there was a talk this morning about land use mapping for Department of Commerce, and I already mentioned to Molly, I'm like, we need to get a hold of those data because that will really help us think about protection urgency because there was information there about development pressures and things like that. So this particular site, also the southern half is already a DNR natural area preserve. The northern half is on Forest Service lands, so we don't see an immediate need to actually get out and acquire the site. So we hope that these 3 ranks can be used to compare sites. A B1 site that is also M1 and P1 is going to be more important for us to get working on as compared to, say, maybe this site. Okay, so to date, we've completed 106 ECAs in this magenta color. I should say Molly has been cranking on those. We've been spending most of our time to date in the field, collecting data, updating the information we have. And so we're now at a point where we're really in production mode of delineating the essential conservation areas. So you can see we got a lot of blue left. So we have a lot of work ahead of us. But we've completed 106, and those 106 essential conservation areas have 33% of the rare plants that occur in the basin, and 19% of the ecosystems that occur in the Puget Sound Basin. And then again, and this information will also be made available on our online data explorer. So we already have a public-facing data explorer that shares the location of rare species and ecosystems, and we'll be adding the essential conservation area layer to that as well. And as I said, it's going to be very useful for us to actually be proactive in thinking about what our next natural area we're going to propose, what that would look like, as well as our partners who are very interested in this information. And I didn't plan this, but I was thinking about the name of our session, Snowcap to Whitecap, and I was like, God, do I have a picture of a snowcap? And I do. So I thought to end the session with Mount Shuskin. So thank you.
Yeah, we can do questions, I guess. Yeah.
Thank you very much, Joe. That was great. I have a question of whether or not you guys are considering how your proto-ECAs might be affected by climate change in the future, and then whether that factors into your decision criteria.
Yeah, in fact, I didn't share it here, but in our proposal, we talked about also assigning a climate vulnerability rank. And I didn't put it up here because we're still grappling with how best to do that. So in the how is it doing question that I had on one of our slides, one of the things that we do for our species, especially is we have a climate change vulnerability index. So it's another methodology that's metric based that results in a vulnerability ranking for our rare plants. And we have, I think, gosh, it might even be 2/3 of them done now. For ecosystems, we are just getting going. We had an EPA grant that Molly worked on to develop a methodology to do something similar for wetland ecosystems. So NatureServe, which is our umbrella organization of heritage programs, has a method for ecosystems, but it's really more, it's more spatial and it's more set up for what we call matrix ecosystems. So ecosystems that dominate the landscape, like shrub steppe in Eastern Washington, or at least used to. And so we wanted to develop a method for more small patch ecosystems like wetlands. So we now have a method. We haven't had the opportunity yet to actually use that tool to assess ecosystems. But a great question, and that's what we were thinking about in this as well, because we're even thinking about that at the species level. How do we balance rarity with the climate vulnerability, you know? And where do you say, oh, there's not much we can do about it? Where can we be proactive? And similarly at a site scale. I will say that when we go to establish a state natural area, we are thinking about those issues as we develop boundaries, or whether or not we want to invest in a site. So, but yeah, we're still kind of grappling with how to come up with a rank at a site level that's systematic and repeatable. And we're not yet there,
yeah.
But
yeah, thank you so much for that. I guess I have a question about where do you see the use of this data going next, aside from, you know, informing decision making in the future, you know, with the pressures of development and growth, and especially certain counties who are working on their comprehensive plan and such. Where do you see this data going next, and kind of what obstacles do you really anticipate with, you know, like, I guess, like, our municipalities, is the onus on them to sort of reach out and ask you for this information? Or is there maybe some sort of mechanism to say, hey, this is sort of front and center data? I guess, yeah, where do you plan on taking this data next? And also, do you see this maybe dovetailing a little bit with the statewide initiatives for things like wildlife habitat connectivity, and maybe being able to implement those concurrently?
yeah. Yeah, so real quickly on the latter, so the Department of Fish and Wildlife is, I don't think it's signed yet, but just developed the 2025 State Wildlife Action Plan. And for the first time, so DFW invited us to be a part of that. And so for the first time, rare plants are in the SWAP, the State Wildlife Action Plan, which is fantastic. So between the state, the Natural Heritage Plan and the SWAP, we now have two, statewide conservation plans that together are going to be hopefully, you know, very effective for guiding conservation. The connectivity piece, again, when we get down to actually establishing a state natural area, we're always looking at those things, because obviously, I mean, generally our state natural areas have been small. And a lot of times that's because that's what we're able to get agreement with the landowners we're working from, including our own agencies. So we struggle with that. But in terms of this information, it's kind of both. Like our element occurrences, our rare plant and ecosystem data are already embedded in a lot of policies. Department of Ecology uses our data in their wetland kind of, you know, rating system. So a wetland that has one of our occurrences in there is automatically a category 1, which has higher mitigation ratios, higher buffer standards, et cetera. You know, counties, as I mentioned, use that in critical areas ordinances as well, typically through the wetland realm. And so we're kind of embedded in a lot of those things around the state, but this would be new and would greatly expand the area involved, right? And so there was going to be a lot of tough conversations there. And I think we are not a regulatory program, so we can't, you know, kind of push this on anyone, right? But I can say that when I've brought this up, people immediately like, where is it? Can I get it? And it's like, not yet, you know, it's coming. But so I think there's interest. But I think to your point, a lot of that is going to be conversations with the policymakers and the people implementing regulatory actions. And we'll see. I mean, I think minimally, again, like the way it's mostly used is the rare plants here do not set foot here, right? And if we can get people thinking, continue to do that, but also thinking what we do around it, that would be important. That's what I hope this information will be used for, as well as proactive conservation. So,
thank you.
Oh, there's no. Wow, all the way in the back.
Thanks, Matt. This is one of those questions that's just shamelessly trying to see if you talk about this stuff in a different way than people in the marine realm talk about this stuff. And a little bit bridging off your question, how much do you think this might contribute to any biodiversity banking efforts that could happen in the future at all?
Yeah.
Do y'all talk about that?
There's no talk in DNR, but I will say the Natural Heritage Network. So there's a heritage program in all 50 US states, all Canadian provinces. And we are a pretty close-knit network, and NatureServe is our umbrella organization. And we've had many conversations about biodiversity banking. As someone very familiar with wetland banking, I have a lot of reservations in terms of how that actually gets implemented and what the actual outcomes are, rather than just the actions. On the other hand, I think if it was done right and well, I think it's an incredible opportunity to really extend the use of this data, but also just conservation in general. And obviously, what is going on outside of North America as far as that is concerned is pretty incredible. And then also, like, how do you bridge that with carbon markets, et cetera? I just think there's a lot of opportunities. I did have someone internally ask me about peatlands, which is my passion, and how we might incorporate them into carbon markets. Because in Washington, we're only talking about forests with carbon markets, and I think we're missing a whole lot of other opportunities there. I mean, there is a lot of biomass above us, but like peatlands, it's all below you, and then shrub stuff. I mean, so anyway, yeah, there's a lot of endless opportunity there. I do get nervous about banking though, and again, it just comes from my experience in the wetland world. But it doesn't mean we shouldn't talk about it. Thank you.
Thank you.
We still have like 3 minutes if anyone wants to ask any of the folks that talked a question, and I can give. So here's mostly our table of people who spoke. Adrienne from Makah, Bart, Zach, Megan, or we can end a minute early. Oh, okay. And I'll give it to the person that you want to ask it to.
Great, thanks. Just a quick one, Joe. Great presentation. I was going to ask, and I thought I was out of time, but this is Providence. It's a big state, and these can be small areas. And I'm curious if DNR sees like an opportunity for like a crowdsourcing approach or an app. I think of Valley Naturalist or other things where people in Washington spend a lot of time off trails, may see things they've never seen before. Could be an opportunity to document and create a database that you could tap into and kind of follow up on. Is there anything like that happening?
Yeah, yes, great question. So we do offer, especially for our rare plants, we have an ability online. Right now, I think it's just a PDF, but we're working on like a Survey 123 app that people can submit data to. So we do get data from, colleagues and other agencies to just, community members submitting data, et cetera. So, but, the elephant in the room, iNaturalist, is a big topic in the NatureServe network of how do we leverage that information. And so there are some heritage programs that are doing a lot with that. We're just now kind of dipping our toes into it because it's a full-time effort to bring that information in, vet it. That's the big thing. The research grade is great, but I've been looking at a lot of research grade observations, and it's not even the same species, right? So so there's issues there, but nonetheless, I still think we could bring in a lot of useful information that way. We are a very small program. You mentioned a big state. We are just now back up to 8 people, and only so yeah. And until a few months ago, we were 6, and that's database, science, administration for the whole state. So it's we've always been under capacity, but back in the Great Recession, we lost half our staff and we never regained it.
Yeah.
So
I'm surprised that you're growing now. That's great to hear, given the state's budget and your colleagues at DFW, I understand, are not getting the support they would like
yeah,
necessarily.
yeah, as we, especially how we fared in 2009, we did okay this past biennium. I'm a little waiting to see what happens with the supplementary budget as it filters down, but and I'm definitely concerned about future federal monies for sure. But right now, I'm just thankful that we did not get slammed like some other programs did.
right.
But the iNaturalist and things like that, we may have to decide that maybe we need to invest time in that as opposed to our own field work, and maybe we get more out of it, those databases than we do collecting it ourselves. So.
Thank you.
Okay. Sorry, we're out of time now, but we do get to go to a break. I have a little bit of instructions on timing real fast, and then you're free. So we're going to reconvene in the grand hall after a break. I think there's some more snacks and things in the back near the river room area where lunch was. And then the final kind of panel and ending starts at 2:55. So it's now 2:31 for a fun panel at the end. And that's all in the Great Hall. So there's no more breakout session rooms. So everybody go back to the Great Hall. Thank you guys. Round of applause for all the people. Thank you.